Hello, folks. It's George Leoniak, and welcome to New Geometry. I'm excited to be here today sharing a video about the spiral. Where does the spiral originate from, and how does it relate to the sacred geometry? There's going to be a little bit of everything in this for people interested in the spiral, some things on the crystal spiral and the golden spiral and their relationship to one another. So join me for this video. I'm going to start sharing my screen, and we're going to revisit first a video that I did a little while ago called Let There Be Light, Golden Spiral Journey with Sacred Geometry. Now, in this video, I was excited to share about where the origin of the golden spiral related to the structural geometry here of an octahedron, right? This is the eight-sided form of the octahedron. And if you extend those edges out in phi proportion, you create a golden rectangle in relationship to a sphere that is around the cube that octahedron is within. And when you do the little crisscross of lines like so, that gives you the center of where the spiral originates from. And there it is. And it originated right on the surface of the octahedron sphere that was around that octahedron in the middle. So that was the origin place, or one of the origins, of the golden spiral in that video. So check out that video for more details. Now, literally the day after I produced that video, I was wondering what would happen if I continued to extend the edge of this is in black now, that octahedron that's at the center. Remember, the octahedron is this form here. You're looking at it like this. We're extending that edge out until it creates past where the dodecahedron was, all the way out to where it creates the icosahedron, if you did that in all different directions. This little model right here, I'll show you at the end as well, is showing you the extension of that octahedron that's at the center of this to create essentially a golden rectangle, a large golden rectangle, and smaller golden rectangles. So there's lots of origins of golden spirals here. We're just going to try and keep it simple. So this is one way to nest the squares and octahedron, all the platonic solids together. And of course, this creates a larger octahedron as well around it. So this is what I discovered after I did that. These are my notes from the summer. I never did this video. I've been sitting on it for a while because I just needed more information. There was another missing piece, which I'm going to get to today. But what happens here is that if I do the little golden lines here, they crisscross, and the point of origin of this spiral is going to be right on the surface. Here's my little rough hand drawn of the dodecahedron, right? The dodecahedron, the 12-sided platonic solid, another phi ratio form with pentagon faces. Well, that crisscross landed right on the surface of the dodecahedron face, on the sphere that's within this dodecahedron that I'm holding. And the origin of the spiral is directly on the center of the pentagon face. And that was where it met, the same center. So it was basically from the icosahedron, that extension line landed right there. That was the origin of our golden spiral and off of that golden rectangle. Now, my recent discoveries, of course, I don't know why I overlooked this and didn't look into it right from the beginning, because it was really pretty obvious. It was right in from my face until I did this drawing with my apprenticeship last week, because we drew a big golden rectangle. Now, remember, inside this icosahedron, if we're looking at it from this view, there's just a golden rectangle. There's straight through the middle of it. And this view that we're looking at it from provides the golden rectangle as if it were flat, just like this, big flat golden rectangle. And we can do the crisscross of the lines to identify where the point is of the origin of the spiral that will relate to this golden rectangle. And it just so happens to be the same spot as the one that I extended with the octahedron edges. They're sharing the same location. So essentially, this is the same information. It still is at the center of the pentagon where the origin of the spiral is. All right, so let's fast forward. I'm going to show some spirals that are going to not traditionally be the ones that you see as if they were quarter arc circles within the squares like this. I decided for this video to do it so the spiral is following the phi ratio progression around the edge of the golden rectangles like this. I don't know, I was interested in the version of that spiral as it went around. So anyway, this is just showing an example of the dodecahedron that is in. I've removed the icosahedron. I'm just looking at the golden rectangle that is in that icosahedron. And when we follow that line, it looks like it's part of the dodecahedron edge, but actually it's going through the center of this pentagon face. This is the same size pentagon. This is an edge length shared at the same edge length of these pentagons. It's just flat to us. Then this line is going through, it's meeting at the vertex and coming all the way through until it meets at this point here, going through the center there. And the other one is going to go straight through the golden rectangle. And that is the point that goes directly through the center of this pentagon here on the side. Okay, so that is the origin of the golden spiral, which was just totally amazing to me, incredible that in this geometry, because I've seen, I see so many images of just golden rectangles, but it relates to the 3D geometry of these forms, and it's on the origin point of the surface of the sphere, not just once, but 12 more times, because each of the pentagon faces are doing this, and more than 12 more times as well. We'll get to in a moment. So I just made this kind of simple construction without building the whole entire form. Here's a photograph of it, but I have it in my hand here as well. Just to take a look at just a very simplified three-dimensional structure rather than our 2D drawings. I've removed the whole dodecahedron edges, but here's the golden rectangle outlined in blue. Of course, with the zone tools, here's the upper golden rectangle. This star point that's coming off of that pentagon, of course, that's the pentagon of the dodecahedron face. Pretend this is just tilted back. That point right there is connected to going through, excuse me, this point here is going through. This is an edge here, excuse me, this is the edge that this line is going through, going all the way to ending at the vertice down here. So as we're looking at this, this is coming down through the edge and going all the way through to that point. So there's a star point coming off that pentagon, which meets at the vertice of this icosahedron right here. So it's really more like a stellated dodecahedron, because if we extend these arms out here, it would basically be a stellated version of this that's creating the icosahedron around it. So the next thing to check out, and I just want to, before we jump to this, I just want to clarify one point about this, just so this section that we're looking at of this edge length of this pentagon is this in flat view. This is kind of a side view of it. This point right here where this arm comes up is this point on the face. So this is the flat edge, just like this flat edge going away from you. And this is the vertice that meets here at the base of this edge. All right, just wanted to clarify that because I might have said it backwards before. So anyway, the golden spiral relationship between the dodecahedron and icosahedron is just fascinating, because you really can't tease apart these two forms, because whenever we do the pentagram faces inside inside this big icosahedron, they automatically make the nested dodecahedron that's within it. And they're both sharing a large pentagon within a smaller pentagon, and they both share the same source of the golden spiral. So it's also right here on the intersection of the dodecahedron face in the middle, and I'll show shortly that there's an icosahedron within inside that dodecahedron also sharing that point. Just having a little bit of fun with the spirals. I'll show you some more of that. You can rotate them around. And, you know, right now, well, what's going on with the center? Well, yes, they're originating, the origination point is from the surface of the pentagon face. And we're going to get to what's going on with the center of the sphere in just a moment. But I wanted to also just show to switch up the view a bit, because we're primarily been in what I call the square view. And what I've done with the square view, and this will become important in a moment, because this is basically taken right out of a square to create the rectangle. What I've done here is I've rotated the image to put it so that the square would be off to the side and the rectangle's off to the side, because this is really looking at the icosahedron from a side view, meaning that if I'm holding it to you like this, that's what you're looking at in the image. This is really spinning around on its vertices like this. So that's up and down, basically, from upper to lower vertices. So it's a side view type of drawing. But of course, we can show this same relationship in the hexagon view. So here's a golden rectangle that is connected to those icosahedron edges. I'm not showing the whole icosahedron, but there's the dodecahedron within there. Here we go. We send our line this way. We send our line this way within that golden rectangle. Now it's a distorted golden rectangle, meaning it's not flat. It's not all the phi proportion is there. It's just not typically how we see them. But it's going through, and you can see this is good to do in the drawings, because then it does just show that everything lines up. That divides the line in half. That divides the line in half. Oh, that's the center point again. And let's do it on another face too. So we've got a more, I don't know, golden flag looking type of rectangle here. And this one is sent through this way, and this one sends through that way. Here's our origin of the golden rectangle on that pentagon face in the middle of that pentagram, which is also the edges of 5 cubes. So right at the center point of those 5 cubed is the origin of that spiral. And this is, of course, the ultimate view for the pentagon, hexagon, the pentagon view, meaning that it is all about the icosahedron and dodecahedron, because now we're looking straight down at them. And this is where I discovered, well, that each of these edges meet the lower dotted edge below. So this is 1 golden rectangle, 2, 3, 4, 5 golden rectangles. And each of those have a spiral that is in this plane. So we can't actually see it from the side, but there are 5 golden spirals coming off of each of these off of this vertex, this one vertex right here. We can reverse that to the other side and have another 5 coming from that direction. So we really would have, just in the strict sense of static geometry here, 5 off of each pentagon face or each vertex times the 12 vertex of the or 12 faces or 12 vertices of the icosahedron, or 12 faces of the dodecahedron. That's going to equal 60 spirals just in all around this thing. But here's another one just highlighted. And this one, I think I did show the 5 orientations of how all of them meet in the middle. And those are creating the edges of the Icosidodecahedron as well, which we'll get to in a bit. I know there's a lot of complex geometry and names that I'm dropping, and I don't have all the visuals for those images. Just picture that it's all super interconnected between just the flat geometry to the 3-dimensional geometry. And I like to bring it to life a little bit by looking at an apple. So if we take this transverse cut of an apple, if in a transverse cut of an apple, I don't know, able apple, let's delete the able part. There we go. So we have a transverse cut of an apple. And what I noticed a while ago is very cool to see the golden circles within the structural makeup of an apple here. And if you look very closely, there's a light decagon ring around this apple, these little dots. Cut an apple this way, look closely for these little dots next time. There are 10 of them. You have a decagon right in the middle of this, as well as the pentagon around the apple itself. And these all roughly line up to 5 proportion of the golden circles. And of course, I can just now drop in our icosahedron and dodecahedron right over this. Although you might be saying, but wait a second, that dodecahedron, that is not, that pentagon face isn't in the center, right? It's up above and down below. So the spiral's not in the center, right? And if you're into the crystal spiral and, something emerging from the center, the spiral from the center, well, this is now the spiral up here and down here on all these faces. It's around the sphere, which could be just a point, really. But what's up with that? So let's just take a look at the crystal spiral, because this is the diagram that is used about these rotating 45-degree rotated squares, one inside the other, that can infinitely go in. Just so you know, this spiral that's being created here will never meet at the center, because all you'll keep doing is making smaller and smaller squares onto infinity, just like anything else. But the mathematics of this are supposed to start at 0 in a doubling sequence. And it's a very cool spiral. I like it. I have a lot of videos on it that are probably my most popular viewed videos, because many people are interested in the crystal spiral. And what I've tried to provide with it is maybe some three-dimensional geometry to this Cathara grid structural geometry, which when I first got involved with it was all very flat, and I didn't understand what they were doing with three-dimensional structures. And from there, it turned into be, at least from my view of it and some other people into it, relationship between the cube and the octahedron, and following the spiral as these cubes and octahedra relate to one another. One way of looking at it that I've hypothesized, since the founder hasn't said what the geometry of this is three-dimensionally. But so we're going to revisit this just for a moment and take a look at this. And basically, I discovered that it's really a kind of unfair view to compare this spiral to a golden spiral at all. Because as I'm showing you here in this golden spiral, as I'm viewing it as in a rectangle, yes, we're looking at it as flat, just like this. This spiral can also be considered flat, but many people feel that it has the look as if it's kind of going in, right? And you could do that with the golden spiral the same way. But basically what I was interested in here as well, based on looking at the icosahedron and constructing it in a square, in square view, I call this square view, there's a golden rectangle at each phase of the square view. So every time a square is counter-rotated like that, essentially the golden rectangle is just going to go along for the ride of each of those squares. So, and each of those golden rectangles are additionally going to have a center point where the spiral originates from. But if you want to just counter-rotate squares, we can do that. But let's take the golden rectangle along with it, because it's very easy to draw in here. I've got another slide in a moment. And this is a flat view that is just continuing to ratchet itself around. And as we do so, the little cross sections, I know it's going to get a little busy in there, but each of these black dots that I've highlighted are the center of one of these smaller golden rectangles where they crisscross all along the way. And what do you know? Of course, because it's following the counter-rotating squares, it's basically a golden rectangle crystal spiral. It's just not based on the same vertices as a square, but we could do that at any point along there. It's just following a very simple method to create a spiral. which is shown here as well. So we are going along and we're creating two spirals based off these golden crystal spirals. Coming from the two, we can do it from the four directions. We can flip them over, because basically what's happening here is this larger circle that is on each square, as you make these out, there are basically dividing from this midpoint to this edge 5 proportions. So these are golden rectangles if you drew the line. And as you go along, they're creating the location there, and they're locating the location on the edge of the square, and the location where the crisscross point is. So it's basically the golden rectangle just ratcheting down and getting smaller as we go, creating the same essential crystal spiral as it goes, because this is the spiral that follows this pattern. When we just rotate squares like that, it's just easy to do and easy for the golden rectangle to follow that appearance as well. Now, here's an example of how we can do just one crystal spiral and one edge of the golden rectangle off of the midpoints here. These circles are ever increasingly getting smaller, and as they do, they are intersecting the square edge and creating the crystal spiral that's dividing the square edge into phi ratio continually along. But we basically have a golden crystal spiral in relationship to the regular crystal spiral. And this, to me, is a much better comparison of, it's essentially the crystal spiral, but it's got a golden rectangle. So it's a more equal comparison. It's of course, the golden spiral is different, but the golden rectangle is part of this crystal spiral geometry just by the very nature that it's found within the square. All right, so I don't know if that's any epiphany or any ahas or anything like that. It's just very interesting to me that it's a better way to represent golden ratio in the crystal spiral flow of that way that spiral is created. But I want to get to where is the origin of the golden spiral, because up to this point, I think that the argument with many folks that are into the crystal spiral is it looks so wonderful because it goes to a center point out of all these squares and octahedron. So far, I haven't done such a convincing job to say, well, we're missing the center point altogether. It's great that it's on the surface of the sphere. I mean, that's mind-blowingly awesome. It's at the center of a pentagon face. That's very cool too. And it's also at the vertex of an icosahedron inside an icosahedron inside of an icosahedron. That golden spiral is basically at the point of any point that there is a golden proportion created is the center of a spiral. So anytime you divide a line, you can picture it like this, because this is the classic union division of a line here, basically, of the line and the circle divided right at this magic point, the golden section on either side of the circle. Classic one that we see between two squares. We'll put a square on top of the square and draw the diagonal between, have a circle in the middle of this width of the square. Then all of a sudden you've created the golden section. It's in the icosahedron. That most ancient root 5 diagram is in the center of the icosahedron. It's all right there. So these are where the golden proportion is found, at this intersection of phi ratio on both sides, center of the pentagon and the vertex of the icosahedron. Totally amazing. And this will go infinite phi nesting of icosahedron within icosahedron within icosahedron, doing that same sort of phi ratio division, circle and two lines on either side, on and on and on. Now, I discovered just this morning that the issue with the icosahedron in the square view, basically, when I call this in the octahedron, we've taken the icosahedron and we've oriented its vertex to the edge length of a square. So this is down in my lower left here where I'm circling around is not the most attractive view, I'd say, of the icosahedron. It looks just kind of like, so, but it's really that we're not even looking at it in a way that is its most beautiful integrity in my mind, because this is the vertex of point-to-point vertex of the icosahedron. So we have to uncage, or at least I did this morning, the icosahedron from the box of the square view diagram. And I've been, that's how I learned how to draw the icosahedron from that view, was from doing the square view. And this morning, a new way to construct this outside of the box at all that goes straight to the heart of sacred geometry and putting root 5 vesica at the center point of the whole thing, going straight down the center. And when we do so, we create the phi division in the root 5 vesica. And that now is the foundation of a whole new diagram that puts the square view, this whole way of drawing it, still a great way to draw it, but it reorients that drawing in a way where all your circles aren't going to get all wonky looking when you rotate your drawing and they're all holding the square symmetry. This is just 5 squares laid out in a row, 2 larger vesicas, which are easy to find in relationship to those circles, and the rest of the points are easy to pick up too. And I'll be sharing how to do that probably at some point. Okay, so the new Icosa construction, not based on the square view, what it really does is it kind of breaks down that twofold symmetry, because here it's very symmetrical in terms of this lower image. You can fold this icosahedron over on top of itself, boom, boom, left and right. You got nice twofold symmetry. One fold up and down, left and right, and that icosahedron all folded up. But now if we fold the symmetry along the root 5 line, we reproduce the icosahedron on the other side, almost as if it's spinning around on its vertex. Because if you did spin this icosahedron, and if I'm holding it this way to you, so that bar is this way, and we want to see the back, let's spin it around. There's the back. Now we've got the opposite side, and this points out here. And if I spin it back around to that side, that points over there. So basically, I'm showing you that if we spun this around this way, now we're going to reverse it, and now the point's over this way. So I'm getting the full circle that is around this icosahedron that's basically within this point to this point over here, that are in contact with the surface of the sphere around this. So, and we have the sphere in the middle, which is the dodecahedron, which is doing the same thing, and it's all pivoting on the root 5 line, square root of 5. Remember, square root of 5. And this is, if this is a 1-inch circle, will leave us 1.618 on this side of the line, 1.6 on this side of the line. And the square view drawing is not needed to do this drawing, which changes the whole flavor and relationship of this and allowed me to see all these new connections that I couldn't see when I was in the square view orientation, which is always drawing it like this. This root 5 line was not very apparent to me until it was all reoriented. So this is why I called it just a moment ago. It's a new golden point of view that emerges. I didn't know what to call this new view, the icosahedron view, the dodecahedron view, because I remember I work with this, like the drawings from what I call the square view, the pentagon view, and the hexagon view. It's very easy to call it. Well, what do I call this one? Well, it's the golden point of view because it is basically centered around root 5 and the division of 5 and the forms that are going to be associated with it, including the cube and the octahedron and all those things. I'm sure there are creative ways to draw them, but the icosahedron needed to be restructured and redrawn with a new view so we can make some other new discoveries like this one here. So I added the Icosidodecahedron in here, and that's very easy to do. Remember, the Icosidodecahedron is this form here. It is either truncating the dodecahedron or the icosahedron at its midpoint along the edges and you come up with this form. And this form is awesome because it's made up of 6 decagon hoops. So if we look at it from the top like this, which is what you're looking at in the drawing here from the top, is basically a decagon of 10 sides of the form that are going around here. It's made up of 60 edges. So you have 10 times 6 would be 6 decagon hoops go around. This is related to the Earth grid video that I did of the 31 great circles. Check that one out. So we have this is how we're going to find the center of the golden spiral, because now if I orient it like we have in the drawing here on the left, and I take my icosahedron, which is outlined in black, and I draw a line straight through the center here, which is this in cross section here. So we're looking down from the top now at this line going across, and as it goes along, it's dividing these triangles of the icosahedron at the midpoint all the way around 10 times, because there's 10 of those triangles all the way around. And then we have a decagram star, and there's our little pentagon in the middle. That is now a pentagon, and with my little criteria that I developed here, where is the origin of the golden spiral? Okay, it's at the point of the golden proportion. Center of a pentagon. Perfect. So any center of a pentagon is going to be the origin of a golden spiral. So this is the center of the spiral. This is also the center of a spiral. In addition to this point here, in addition to this point here, in addition to so many points, it can go on infinitely where all the points are. But if we want to put it at the center of the sphere of this diagram, this is how we've discovered it, because right inside this geometry of this big icosahedron is the Icosidodecahedron. It's already a given. It's basically dividing these triangular faces at their midpoints, decagram star, small pentagon. It's right there. And of course, it fits beautifully into our apple scheme. So here is our apple, and we have the Icosidodecahedron now lining up with the exterior of our apple. I know it's one apple out of a gazillion, but it's just a loose representation just to make a visual reference to how that center of the apple has that pentagram star, and the decagram is around it, and that creates a pentagon that will be in phi proportion to this outer edge length that we're looking at here of the outer circumference of the red circle here that's going around the apple itself. So it all just kind of matches up. And if we look at it from a side view, of course, now we can look at that apple and looking at relationship to the torus, and we have a vertical column going through this, which is the root 5 line through the center of this. And then we could see that the outside of this apple is in relationship to the circumference of that circle as well. And there's our decagrams that would be through the middle, which is this decagram, the decagon of the edges of the Icosidodecahedron. And here would be our inner 5-pointed star right in the middle as well. So, it's a loose, it's a loose relationship there that, I'm just using some rough visuals, but hopefully they help, take this structural geometry and relate it back to something that is organic. And is there a relationship to the torus? Because the apple is often thought to have a very toroidal looking shape here. And maybe that this relationship to how the spirals are related to this torus originating from the center or at different places within it are related to this pentagonal geometry of these forms. With very different than thinking about this all from the, which is so popular, is the Merkaba view with our tetrahedron points like this. This would now be all about the Icosidodecahedron, but see, there are very strong reasons that are adding up to why the toroidal spin of things may be more related to this icosahedral structure. I mean, maybe it's both, of course, but the way that I see this as well, I'm seeing it now in the apple and the torus shape here, and with the pentagon at the center of it, as well as the Earth grid video of the 31 great circles that's been researched by scientists like Buckminster Fuller and Russian scientists or putting the whole Earth into an spherical Earth into an icosahedral framework that has the vertex at the north and south poles. So that is just another reason why they're think about the icosahedra as the root 5 line going through the center as being the origin of the funnel of spirals that are along that axis. So let's just have a little bit more fun with it. That's all, speculation based on what the geometry looks like. But, these are fun little things I like to do and lay a little human body in here because we love to look at kind of Vitruvian man type of images and see how we all lay out with the structural geometry of what's being shown and get a little wild with the spirals here and or have one at the center of the apple going up and have one the other ones are at the cross section across the icosahedron here, and those spirals are going up and around and following the edge of the apple. I mean, it's just a lot of fun to play around with these sort of things and get another frame of reference that's based on this column of pentagrams of ever smaller and smaller sizes or larger sizes going straight through the middle. And those are all the origin of golden spirals all the way along. So let's just take a quick look at some of the models that have been constructed for this. Here was the one of the, this is basically an icosahedron of the golden rectangle that's in the icosahedron. This would be the stellation of the decagon or the dodecahedron within there going up to the vertice down here. We could do it at the bottom. We could do it at these points. This is just one of 15 of these that it would be in there because there's one for each, one golden rectangle for two edges, each of the two edges of that. So we've got the golden rectangles in there, and there's the origin of the spiral that would be right at the center point. If we hold it this way, that line going down this way would be there. I think that was all clear in the video. There's another one of the icosahedron with the dodecahedron with the tetrahedron. The cube is in there, and the octahedron and the tetrahedrons in the middle. So this is showing if we extend that edge all the way up from the octahedron that's down in there, creating this icosahedron around it as well. So I hope you enjoyed this video and that it was, mind expanding around the relationship of the spiral as it relates to the golden spiral, that is, in relationship to the pentagon face. Remember, key points of this, that golden spiral, based on what sacred geometry has shown me from many, many different views, is saying that anytime there's a division of a line at the golden ratio point, then that's a spiral a place that the spiral originates from, the center of the pentagon, and inside this is a 12 verticed icosahedron. This form is down in there, and that's also the meeting point of the center of the spiral as well. So it's at the vertice of the icosahedron, the spiral. It's at the face of the pentagon in the center of it, and at the golden ratio point. So the spiral is so cool that it's at all those points. And anyway, that's all I got for you today. So thanks for watching, and I look forward to hearing about your questions and comments in here, and I appreciate you watching. I'll be doing drawings like this in my Patreon and apprenticeship, so look into those. There'll be some links over there, and please subscribe and like this channel, and also, or like this video. And I have a Facebook group with new geometers, so join there because there's about 2,000 people in there sharing all sorts of cool sacred geometry stuff. So thanks again for spending some time with me, and much love and appreciation. Bye.